This video is going to do several examples of writing linear equations from a given graph. We are specifically only going to look at slope-intercept form, and that's the form y equals mx plus b. M is the slope and b is the intercept, so it's called slope-intercept form. Our first graph is here, moving van costs versus the distance that you drive this moving van. Here we see a y-intercept at 0, 30. That means that if you drive 0 miles, it costs you $30 to rent the van. That essentially means that you pay a $30 fee before you take the van off the lot. And then we have to consider our slope. So I'm going to look for another point that has whole number coordinates. The next point that has that is here, 20, 40. So from 0, 30 to 20, 40, we need to consider what the rise and the run are. In this case, the rise is $10 from 30 to 40. And the run from 0 to 20 is 20 miles. So the slope here is 10/20ths, or 1/2. That to me says that for every additional mile I drive, it costs me an additional $0.50 or 50 cents. So if I drive 20 miles, it's going to cost an extra $10. We're ready to write our equation now. Y equals the slope 1/2 times x plus our y-intercept of 30. Okay, the y-intercept there 30 means that if I plugged in x equals 0, y would equal 30. Our second example has a y-intercept at 0, -1, so the b value is -1. And next we need to check the slope, so we need another point that goes directly through grid marks. And I think there's one here at 2, 0. So we need to analyze the rise and the run in order to determine the slope. From -1 to 0, here, the rise is +1. And from there over to 2, from 0 to 2, there is a run of +2. So again, our slope is 1/2. This means our equation in slope-intercept form is y equals 1/2 x minus 1. Okay? Remember that it's y equals mx plus b, so when b is a negative number, we have a subtraction sign there. Example 3 has a y-intercept at +1. Then we need to analyze the slope. Our next coordinate point is at 2, 0. So in fact, this time our rise goes down, which means it is a negative rise. So it goes down 1, so we need to say that it is a -1 rise. Then we still go over 2, just like in the last example. To the right 2 means we've gone a run of +2. So in this case, our slope is -1/2. Notice how here the graph tilts down to the right, and on the previous example, the graph tilted up to the right. Negative slope always goes down to the right. So in this case, our equation is y equals -1/2 x plus 1. And our fourth example has a y-intercept of -1, and then we need to analyze our slope. It looks like there's another coordinate point here at 1, 1. So to determine the slope, we need to first look at the rise. From this point up to this point, I've gone up 2, from -1 to +1. So my rise is +2. And the run is 1 unit to the right, so 2 over 1. 2 divided by 1 is just 2, so we can leave that as the whole number 2. Our final equation then is y equals 2x minus 1. Our fifth example has a y-intercept at -2. Then we need to determine the slope. So let's pick another point. This point is 2, -2. Okay, see, out 2, -2. So first we need to determine the rise and then the run. Well, the rise from -2 to -2 is nothing. It hasn't gone up or down any. So in fact, the numerator of our slope is 0. The rise is 0. And the run is +2, from 0 to 2. Well, 0 divided by anything is 0. If I have 0 pies and share it among 2 friends, nobody gets any pie. So the slope in this case is 0. Well, if we plugged that into our equation, y equals 0x minus 2, 0 times anything is 0. So this 0x term just becomes 0. We know that 0 minus 2 is negative 2. So in fact, any horizontal line like this, the x term is going to drop out because the slope is 0. And we'll end up with a y equals a constant, like negative 2 equation, that signifies a horizontal line with a 0 slope. Our last example today does not have a y-intercept. It doesn't mean that our y-intercept is 0, okay? That would mean that there is a point here at 0, 0. What this means is that there is no y-intercept. A b-value does not exist for this graph. Let's see if we can figure out the slope then. Well, slope is rise over run. So let's take a look at what we have on our graph. Here there's a point at 3, 0, and here there's a point at 3, 2. Well, the rise is up 2, okay, we move up 2 units, and the run, the amount we move left or right, is nothing. We haven't moved to the left or right at all. Well, we can't divide by 0, okay? Dividing by 0 means it's undefined. So in this case, our slope is undefined. Well, if there's no y-intercept value and there's no slope, how are we going to write this in y equals mx plus b form? And the answer is that we're not. We're not going to write this in mx plus b form because we can't. Remember that last example we had where there was a horizontal line at y equals negative 2? Well, that had a slope of 0, and it only mattered what the y value was doing. The y value was negative 2 the whole time, but the x value always changed, and it didn't matter what the x value was doing, the y value was just always going to be negative 2. We have a similar case here, except that now it's the x value that's staying constant through this vertical line, and it's staying at a constant value of 3. So in fact, for any vertical line, our equation is x equals some constant number, and in this case that constant number is 3. So remember, when you have a vertical line, there's essentially infinite steepness to that line, which means that our slope is undefined. So our vertical line equation is x equals whatever constant term it goes through on the x-axis.